So section 2.2 in college algebra is split into two parts. This is the first part of 2.2 where we're just going to solve linear equations and models. The second part is very heavy on the applications, and we're going to be doing a lot of what we call chart problems. So first, when you solve an equation or try to solve a linear equation, you can end up with one of three options, either at the identity, the conditional statement, or contradiction. So we all know how to solve a linear equation, but the result tells us what we have. So the contradiction is something that's really easy for me to see. You're going to end up with something like x plus 4 equals x plus 5. Now, that can never equate because 4 does not equal the same value as 5. So that's one example of what a contradiction might look like. If you see that the x's will cancel out in any example like that, and you're going to end up with something like negative 3 equals 8. Well, you know what? Negative 3 does not equal 8, so there's a contradiction there. And technically, we would say that in this particular case, whoops, that's a solution. There's no solution to that statement. The conditional statement is what you get when you normally would solve an equation. So you're going to do a lot of work and you're going to end up with something that you can solve. So 3x equals 8, and therefore you would solve it and say x equals 8/3, or x equals 0, or x equals negative 2,143. Those are all examples of conditional statements from a linear equation, and they're conditional because for a certain value of x they are true, and the identity is he equals himself basically. So 2x plus 1 equals 2x plus 1 when you do a little work. Maybe you end up with 4 equals 4. You will notice that in the top one and the bottom one, the identity and the contradiction, the x's will end up canceling out. If you take it all the way to the last step in the identity, you're going to see that it comes out to a true statement. 4 does equal 4. In a contradiction, it's a false statement. So it's not that there's no solution for an identity, it's that there's many solutions, because technically they are the same line, so they intersect at every possible point. So here we can't tell right off the bat if they're identity, conditional, or contradiction, so you got to do a little bit of work. So we're going to have 3x minus 6 minus 2x minus 2 equals x minus 8. Now you don't even have to go all the way to solving it, but I will notice that we end up with x minus 8 equals x minus 8. He equals himself, so this is what we refer to as the identity. So here I'm going to distribute the 2. Whoops, that would be a 6, Abruzzo, 6, plus 3x equals 3x minus 8. So I notice on this question, we're going to end up with x's left over. Like 5x minus 8 equals 3x minus 8. Now, even though the 8's are going to end up canceling out, the x's do not, and since I still have an x in the problem, that means this is a conditional statement, because for one value of x I will find an answer. It turns out it's 0. Number 3, 5x plus 10 minus 3x plus 3 equals 2x plus 4. So that would be a 2x plus 13 equals 2x plus 4. I don't think so. 13 is not the same value as 4. Normally in Algebra 1 we would say this is no solution, but today we're going to call it a contradiction. And then here is a rational equation that we would have to solve by multiplying through by the quantity x minus 2. So you end up with 3, plus 1 times x minus 2 is x minus 2. And then x minus 2 will cancel, equals x. So we have x plus 1 is supposed to equal x plus nothing, and that is another contradiction. Sorry about the handwriting. Okay, so for the rest of these, we're just going to be solving the equation. I don't know about every single one of them, but most of these come out just to have conditional answers, so x equals 5. Or if it turns out to be a decimal, unless it's an application, I prefer fraction answers. So if the directions say otherwise, please make a note of that. So we're distributing the 2, and then we're going to collect whatever we can. Now I notice you guys make some silly mistakes when you're in a bit of a rush, and I'm guilty of that as well. I'm going to add 3 to both sides, and I'm going to get t equals 8. So here, I don't like fractions, so I'm going to multiply everybody by a 12. What that's going to do is create a situation where I no longer have a fraction. So that's a 6d, and then 12 divided by 4 is still going to leave me with a negative 3 that I'm going to have to distribute to the 2x minus 1. And then 12 divided by 3 is still going to leave me with a 4 that I'm going to have to multiply to the x plus 2. So I don't know if that made my life better or not, but I just really don't like fractions, so if I don't have to work with them, I'm happy. That's a 63 equals 10x plus 8. So let's see, that's a 55 equals 10x. So that's an x equals 55 over 10 would be 11 halves. Another rational equation that if I wanted to get rid of my denominators, looks like I'm going to need a 9 and an m. Now when I multiply a 9m into everybody, the first term, the m's are going to cancel. 9 times 1 is 9. The second term, the 9's will cancel. Negative 1 times m is negative m. Same issue on the third term, the 9's will cancel, so I have a 4 times m. And then in the last term, 3 and 9 will divide out to a 3, and the m's will cancel. So negative 2 times 3 is a negative 6. So I'm going to, let's see, add the 6, add the m, find out that m is 3. Okay, we're going to have to FOIL out both sides of this equation, which I know appears to produce a quadratic at first, but something amazing is about to happen. When you have two quadratics equaling each other, oftentimes you will see something kind of cool. I notice the x squareds will cancel, I notice the x's will cancel, and I get negative 6 equals negative 20. Well, that's not true. So you can write no solution, because that's technically the right answer, or you could call it a contradiction, because negative 6 does not equal negative 20. Okay, similarly, here on this problem, is this the same problem again? Nope, a little different. Okay, x squared minus x minus 6 equals x squared plus x minus 20. Now the x squareds will still cancel. But this time, if I went ahead and added the x over, I'd end up with 2x, and if I added the 20 over, I'd get equals 14. Now I get a conditional statement that allows me to solve for one condition of x. And then number 6, big parentheses around the whole thing because I hate fractions. I'm going to multiply every term by the quantity x plus 4. In the first term, the x plus 4's will cancel, leaving you with 2x. And then 2 times the quantity x plus 4. I know you can distribute that in your head, but be wary of mistakes. And then the last expression, the x plus 4's will cancel, so it's just a minus 8. Whoops, hello. Equals 2x plus 8 minus 8. The 2x's will cancel, and we end up with 0 equals 0, which, although it's not helpful, it is a true statement. This is the identity, which means that we have infinitely many solutions. So just tell me, just say it is an identity and it has many solutions. That's a good enough answer for us. If the book tells you something else, then do whatever the directions they want for the book. So the next part, I just want you to set up mathematical expressions for me, because what we're going to do in the next part of 2.2 requires that you're really good at this. So the width is half the length. I'm going to use W for width. He is half of the length. The length is, now be careful about less than. Less than is backwards, so when it says 2 less than 3 times the width, you actually have to put 3 times the width first and then subtract 2. And then the width is, and again, less than shows up, 8 less than the length. So width is 8 less than the length. Applications, oh geez. Well, guess I better get a book. So on page 149, hopefully you have your book too, so you can look at what I am referring to. Page 149, number 75. Oh, it's a chemistry question. So I'm a real visual learner. I like to see what is happening, and then I can set up the algebra off of that. It says how many gallons of water must be mixed with 50 gallons of a 30% alcohol solution to obtain a 25% solution. So we are diluting it. So what's happening here is I got this beaker that's going to be water, and then this beaker that's the 30% solution. And when I add them together, I'm going to get a new beaker with my 25% solution. So this is water, which if I ask you how much alcohol is in water, you better tell me 0. Now the other thing you need to realize is they don't tell me how much water I'm going to add. So there is X gallons or whatever of water in there. And then for this guy, it's 12 gallons of a 30% solution. So 30%, and I've got 12 gallons. And then my final beaker, I'm supposed to have a 25% solution, but when I ask you about how much is in there, it's the 12 gallons plus how much water I added. So there's X plus 12 gallons in there. Now with these beakers set up, I'm ready to set up my equation. What you do is you multiply the percent of alcohol times the amount of liquid in there. So 0% times X is 0X, which is nothing. And then 30% times 12 gallons, we'll figure that out in a minute. And then 25% times his amount of gallons would be the X plus 12 quantity. So 0 times X is nothing. We get 3.6 for 0.3 times 12 equals 0.25x plus 3. And now I'm going to solve for x. So I'm going to subtract 3 from both sides and get 0.6 equals 0.25x. And I never trust my brain when it comes to dividing decimals, so excuse me while I type. And I get 2.4, and I don't remember the label. What was it? Gallons. And you want to label your answer really clearly, gallons of water, or H2O if you'd like. Very good, 77, same kind of idea. This time we're going to mix water with a 90% solution to produce a 50% solution. And they told me 5 liters of water is used. How much of the 50% solution is produced? Okay, so again, we've got our 3 beakers, our 2 little beakers and then giant beaker at the end where I mix them together. I've got water, and I think they went ahead and told me that I added 5 liters of water. And then a 90% solution. And I don't think they told me that. And then we're supposed to produce a 50% solution. Now, if I have, 5 plus x is how much liquid I have in the final beaker. So 0 times 5 is 0. I'm not going to write it down. 0.9 times x is 0.9x. And then 0.5 times 5 plus x, or x plus 5. So we're going to solve this equation, and we have to be careful, I think, because this is classic trickery. They don't actually want to know the x. So 0.4 when I subtract equals 2.5, and again, I never divide in my head because it has failed me many a times. So x is 6.25, but remember, this represented how much of the 90% solution we're supposed to add. I think they wanted me to find out how much 50% solution was produced. So 5 plus the 6.25 is 11.25, and it was liters of a 50% solution. And that's the answer they're looking for. So watch out, make sure you answer the actual question. There's a follow-up lesson to this that has way more of these chart problems that you are probably going to want to look at.